Intro to Gas Law
by Jenna Valvano
and Jonathan Paradiso.
Our objectives for today are to identify the characteristics true of all gases, explain how gases exert pressure, explain the difference between how gases diffuse and how they are compressible, identify the gas variables and explain what they mean, define atmospheric pressure.
Practice how to convert to Kelvin. Identify 3 units of pressure. Identify the standard conditions to measure gases. Kinetic molecular theory. The particles of gases are considered to be small, hard spheres with an insignificant volume. The particles in a gas are rapid, constant, and random.
All collisions between particles in a gas are perfectly elastic. The average kinetic energy is the same for all gases at a given temperature. Gas particles undergo no intermolecular attraction or repulsion. Gases are compressible and also diffuse. They are compressible because gases are less dense than other states of matter. They have fewer atoms or molecules per unit of volume. There is more space between the molecules, and they're easy to compress into a smaller space.
Diffuse. Have more kinetic energy and are smaller than liquid molecules. Small size enables them to move through small openings, able to diffuse through each other very rapidly. Have continuous random motion of particles.
Gases exert pressure. Gas pressure is the result of simultaneous collisions of billions of rapidly moving particles in a gas with an object. It results from the force exerted by a gas per unit surface area of an object.
The force a single particle exerts is extremely small. For example, air exerts pressure on Earth because gravity holds the particles in the air in the Earth's atmosphere. Gases variables. Gases are measured with 4 different variables. They're measured with pressure, volume, temperature, and amount.
Gas variables. Gas properties can be modeled using variables. V equals volume of gas, and it's expressed in liters. T equals temperature, and it's expressed in Kelvin. P equals pressure, and it's expressed in ATM. N equals the amount, which is expressed in moles.
Expressing temperature. Temperature is expressed in Kelvin. To convert to Kelvin, use K equals degrees Celsius plus 273.15.
To practice how to express pressure, you're going to convert 25 degrees Celsius to Kelvin and convert 177 Kelvin to degrees Celsius. For your first practice problem, you know that K equals degrees Celsius plus 273.15. Therefore, you're going to plug in 25 degrees Celsius plus 273.15, and that's going to give you K equals 298.15 Kelvin, and this is your final answer. For your second practice problem, you know that K equals degrees Celsius plus 273.15. So you know that 177 Kelvin equals degrees Celsius plus 273.15. And you're going to subtract 273.15 from both sides, so minus 273.15 minus 273.15. And you're going to get degrees Celsius equals negative 96.15. And that's your final answer.
Units of pressure. ATM, or standard atmosphere, a unit of pressure. It is the pressure required to support 760 millimeter mercury in a mercury barometer at 25 degrees Celsius. kPa, kilopascals. This unit is inconveniently small. for many purposes, and it means 1,000 newtons per square meter.
mmHg or torr means millimeters of mercury. It's a unit of pressure equal to 1 torr or 133.3 pascals.
Standard pressure. Standard temperature and pressure are defined as the temperature of 0 degrees Celsius and a pressure of 101.3 kPa or 1 atm. 1 atm equals 760 millimeter mercury equals 101.3 kPa. Practice problems. Change 1,656 kPa to atm. What pressure in kPa does a gas exert at 385 millimeter mercury?
For this practice problem, you're going to change 1,656 kilopascals to atm. So you know for this problem that 1 atm equals 101.3 kilopascals, which is equal to 760 millimeters of mercury. So you're going to start off with 1,656 kilopascals over 101.3 kilopascals. This would be 1 atm. The units are going to cancel, and you're going to multiply these and divide these, and your final answer is going to be 16.35 atm. The question for this practice problem is, what pressure in kilopascals does a gas exert at 385 millimeters of mercury? So your knowns again are 1 atm equals 101.3 kilopascals, which is equal to 760 millimeters of mercury. So what you're going to do is you're going to start out with 385 millimeters of mercury. Then you're going to make your train tracks once again. And you are going to put that over 101.3 kilopascals and 760 millimeters of mercury. And what you're going to do is you're going to multiply this, and then you're going to divide by this, and that gives you a final answer of 51.32 kilopascals.
Atmospheric pressure. The pressure exerted by atoms and molecules in the atmosphere surrounding Earth, resulting from collisions of these particles with objects.
The standard conditions to measure gases. The standard conditions to measure gases is a standard temperature and pressure, or STP, which is defined as a temp of 0 degrees Celsius or 273.15 Kelvin, and pressure of 101.3 kilopascals or 1 atm. To find volume, you use the ideal gas law, which is PV equals nRT. P is the pressure in atm, V is the volume in liters, N is the number of particles in moles, and T is the temperature in Kelvin. R is the ideal gas constant, which is 0.0821 liters of atm per moles Kelvin.
Practice problem. Calculate the volume of 1 mole of gas at 273 Kelvin and 1 atmosphere of pressure.
For this practice problem, you would use the ideal gas law to find the volume of gas. So you're going to do 1 atm times the volume equals 1 mole times 0.0821 atml divided by the mole of K times 273 K. Therefore, the volume will equal 1 mole times 0.0821 atm liters over the mole of K times 273 K divided by 1 atm. And your final result would be 22.4 liters.
Recap. Gases are measured with 4 different variables. Gas diffuse are compressible and exert pressure. The kinetic molecular theory lists characteristics true for all gases.